Hey there, Coach Spots again. Today we're going to talk about perpendicular and parallel lines. I'm just going to give you guys a brief introduction to this because it's kind of a review of stuff that we've already gone over or that we've already taught. But write down these two sentences. This is the definition of the slopes in relation to parallel lines. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slope. I'll say negative reciprocal slopes of each other. Meaning if one is positive, the other is negative. Okay? So opposites are in opposite directions. If one is in a positive direction, the other is in the opposite direction. That is the negation of that. That is the negative of that. And then reciprocals, remember what was in the numerator is now in the denominator. And opposite there. What was in the denominator is now in the numerator. So our fraction flips, or if we have a whole number, it becomes a fraction as that value becomes the denominator under 1. Okay? So let me give you guys some examples of parallel lines. Parallel lines have the same slope. That would be one line has a slope of 3, and the other line has a slope of 3. Okay? Or 13 and 13 would be the same slope. Or a slope of 5 and a slope of 5, right? They would have the exact same slope, okay? Perpendicular lines have opposite reciprocal slopes. What that means is if I have one value that's a positive number, then the other slope needs to be negative, okay? Here I've got a positive 3, so my opposite would be a negative. The reciprocal of 3 is now 1 divided by 3. So 3 and negative 1/3. Okay? And I'm actually going to focus on having several more examples of perpendicular lines because that's the one that's a little bit more difficult. So 3 and negative 1/3, negative 2, and now positive because we have the negative value already. So the other one would be positive 1/2. Okay? If I was given the fraction first, like 1/4, then the perpendicular slope to that would have now been, this is positive 1/4, so we want a negative. And then flip the fraction, 4 over 1 is just 4, so negative 4. Okay, so these are examples of slopes that are perpendicular to each other. Okay? So let's go back. Parallel lines have same slope, perpendicular lines, opposite reciprocal slopes. Let's give you some examples of parallel lines as an equation. So putting it in slope-intercept form is the best way to identify if two lines are parallel or perpendicular, or neither. They could be neither, right? Parallel means they run train tracks to each other. Perpendicular means they meet at a right angle. Right, so there's a 90-degree angle between them, even if that is tilted. Right? Here we have a positive slope, negative slope. But of course, we can have two lines that are neither perpendicular nor parallel. Right? So there's options there. Okay? Like these have slopes that are just random. Okay? Slope-intercept form I love because it allows us to easily compare the slopes of them. If we're in slope-intercept form, and they're already solved out, y equals 4x plus 7, we could compare this line to another line very easily. Y equals 4x minus 2. These are two totally different lines, but they are parallel to each other, and the reason we know that is because in slope-intercept form, we find our slope as a coefficient of our variable x. Remember, slope-intercept form is y equals mx plus b. And so for each of these problems, we have a slope of 4. And since we have a slope that is identical, then we know they are parallel. Okay? Let me make some changes on this board really quickly. So let's say I were to change this number right here. No longer is it 1/4, or sorry, no longer is it 4. Now we'll say this is negative 1/4 x. So this equation and this equation are given to us. We want to identify, are they parallel, perpendicular, or neither? Again, look at the slopes. This slope is now different than that slope, so they're definitely not parallel. So we would say right off the bat, not parallel because they're different from each other. So let's identify if they are perpendicular. So I have a 4 and a negative 1/4 for our slopes. If you notice, one's positive, one's negative, and this is the reciprocal of that. So we know right off the bat that these are perpendicular. Let me spell that better. Perpendicular. Okay? Now, if this was missing the negative, and it did not have a negative there, this would no longer be perpendicular. This would be a scenario where these are neither parallel nor perpendicular. Okay, the same would be said if instead of 1/4, if our slope was -4. Okay? So if I had a -4 right here, those are not the same, so they are not parallel, and they're not reciprocals of each other, so they're not perpendicular, so they would also be neither. Okay? Y equals -5x plus 7, y equals positive 1/5 x minus 2. Okay. Are these parallel, perpendicular, or neither? We would call these, again, perpendicular, because we have opposite reciprocal slopes. If all of a sudden I made that a negative, then it would be neither. Okay? Because they need to be opposite, meaning opposite signs, meaning one is positive, one is negative. Okay? This is in the slope-intercept form. Now, oftentimes, you will not have a problem in slope-intercept form. You'll be required to get it into slope-intercept form. Okay? Meaning, you might have 2x plus y equals 7, and you might have -4x plus 2y equals 8. You will first be tasked with solving them for y. So solving this for y means I move the 2x over by subtraction, and now it is in slope-intercept form. Over here, I move the 4x over by addition, and then I have to divide everything through by 2. You get y equals 2x plus 4. Okay? You'll notice when I do this, I have a slope of -2 and a slope of +2. They are not the same slope, therefore they are not parallel. So this is not parallel. They're also not reciprocals of each other, so they're not perpendicular. This would also be a scenario where they're neither. Now the cool thing about identifying problems like this is we just need to identify the slope. That's it, and compare it. Okay? In this specific scenario, the slope-intercept form is not the only form that we can use. We could have also used the point-slope form, because the point-slope form includes the slope. Literally, the slope is right there in the point-slope form. So if I had one equation in point-slope form, and if my other equation, I don't know, we'll say, is in slope-intercept form. So this is point-slope form right here, this is slope-intercept form. Either way, we have the slopes right off the bat. We know this slope is 1/2, we know this slope is -2, therefore we know that they are perpendicular, okay? Because they are negative reciprocals of each other. So that's how we do this.